Okay, so good morning, mabuhay, and blessed be God forever. Welcome to science class today. Okay, so before anything else, may I know first, and let me remind everyone, okay, to prepare the following. Okay, so first, kindly prepare your science module, your pencil and pen. Okay, also your whiteboard pen. Okay, again, let me remind everyone while waiting, kindly prepare the following. Kindly prepare your module, okay, your module, also your pencil or pen, and your whiteboard and is it clear? Okay. Now let us proceed to the next part of this day. So kindly remember this during our class time, okay? So first, you need to focus. Don't forget to focus, okay? Second, kindly listen carefully, okay? Listen carefully. Third, always mute your microphone if you are not asked to talk to. Fourth, kindly raise your hand if you want to talk. Okay, and the fifth and sixth is, okay, don't forget, is you need to always turn on your camera so I can see you and always. And is it clear? Give me a thumbs up if yes, a thumbs up if no. Very good. Okay. Now let's proceed on the next part. So before anything else, before we have our or discuss our first lesson in science for this school year, may I know how are you? Okay? So give me a thumbs up if you are okay or a low and a happy if you are okay today. Or you can also give me a wow face if you are surprised and feel fantastic and awesome for today. You can also show me if you are sad or very upset. Okay, at the count of 3, 2, 1, go. Okay. So whatever you are feeling right now, I hope that our lesson will make you feel more comfortable and enjoy our day. Okay? So let me proceed now on the next part of our day. Okay? So what's for today? Okay? What are we going to do for today? Okay? So the first part of our day will focus on our review. We will have our discussion, review activity 1 and review activity 2. So what is this review? So the first part, the review time, will focus on the things that we had last time, and it is starting right now. Okay, so what are we going to reminisce or remember from our previous year? Okay, last school year in science. Okay, so I think last time, okay, we encounter a man on the screen. Who is this man? Okay, do you have an idea? Maybe some of you will say that is Albert Einstein. Okay, some will say that is Dr. Jose Rizal, but no, it is not Albert Einstein or Dr. Jose Rizal, but this man is Mr. or Sir Isaac Newton. Do you still remember him? Okay, some remembers it, some wouldn't, right? But again, this man on the screen is Mr. Isaac Newton. Can you say Isaac Newton? Very good. Okay, so that is Isaac Newton. So Mr. Isaac Newton, right? He is the one who introduced us gravity and the word motion. You still remember gravity and motion? Last year, right? We studied about gravity and motion, and I hope you still remember it. Okay? So this gravity and motion gave us an idea, or Mr. Isaac Newton or Sir Isaac Newton gave us the knowledge and idea why things have gravity and why things are doing or having motions or movements. Okay? So that is our review. So we're done with our review. So I think we can now go on with the next part of our day. And this is our discussion time. So our discussion time is connected with our review a while ago, which is Isaac Newton, right? And gravity and motion. Why is it connected? Okay, so let me start this day by showing you again the picture of the man that I showed you a while ago. And this is Mr. Isaac Newton, okay? Because our first lesson for this school year will focus on the law of motion that Sir Isaac Newton has shared to us, okay? And the title of our lesson one is Newton's laws of motion. Can you repeat our lesson one or the title of lesson one? Say Newton's laws of motion. Go. Good job. Okay, so let's proceed now on our discussion for Newton's laws of motion. Okay, so let us first reminisce or review who is Mr. Isaac Newton. Okay, so again, Sir Isaac Newton was born in the year 1642. He is an English physicist and mathematician. Okay, that is why he focused on gravity and motion, right? Because that is his expertise, okay? A physicist and mathematician. Okay, also, he is the one who discovered the law of gravity and the things that we're going to focus today, which is the three laws of motion. Okay? Okay, so again, let me repeat, Mr. Isaac Newton will help us to understand the three laws of motion. Okay? Don't forget that. Okay, so let us first define Newton's law of motion. What is this all about? Okay, as you can see on the screen, says here that describe the motion of all objects on the scale we experience in our daily activities. What does it mean? It means that Newton's law of motion will give us, okay, a clear understanding why, okay, why an object move like that or have a motion like that, especially the movements that we have on our daily activities. Is it clear? Okay, very good. So, the first law of motion is the law of inertia. Can you say law of inertia? Go. Okay, so that is the first law of motion, the law of inertia. What is law of inertia? Can we, everybody read? You read with me, okay? So law of inertia is an object at rest stays at rest, and if moving, will keep moving in same velocity unless there is unbalanced force. Okay, good, thank you. So when we say an object at rest, when we are resting, we are not that moving, right? Resting is you are stopped, you are not doing anything, okay? So it says here that law of inertia means that if the object is not moving, okay, it will stay on its place and it will not move unless there's another object that will let it move, wherein the unbalanced force will be applied. Okay, the unbalanced force is another movement will be done, okay, will be done by the object, okay, and another object. So for you to understand it more, here is an example. As you can see on that picture, okay, on that picture, at first the football or the football, okay, or the soccer ball is not moving or remains at rest, right? But when the foot, okay, let it move by kicking it, it has an unbalanced force that gave the ball a chance to move in an unbalanced way or unbalanced movement. Okay, is it clear? So there is an applied force, unbalanced force on the football from the foot itself. Okay, so there is an active unbalanced force. Another example is the glass and the paper and coin. Okay, so on the first part of the picture, so the coin is not moving. The coin under the paper is not moving. Okay, but when the hand, okay, move the paper, the coin fell down inside the bottle, and there is another movement being applied, and there is also an unbalanced force. That is how law of inertia explains the movement or the motion of an object. Is it clear? Okay, so another video. Okay, that one. Okay, so again, law of inertia, when the object is at rest, it will stays at rest, and it will just move if there's another object that will keep it moving. Okay, so again, what's the first law of motion? It's, say, law of inertia. Very good. Okay, now let us go on to the next law of motion. What is this law of motion? So the second law of motion is, everybody say, law of acceleration. Go. Okay, so law of acceleration. What is this law of acceleration? Okay, so let's read it in 3, 2, 1, go. Acceleration of an object is directly proportional to the force and inversely proportional to the weight of the object. Okay, what does it mean? So we studied acceleration before, right? We studied acceleration before. And it explains here that, okay, that there will be the same speed, there will be the same different also speed or weight of an object when the law of acceleration is being applied on the motion of the object. Okay, so one example is this one. At first, okay, so the first man is pulling one box, right? One box. So the man pulling the box, okay, applied acceleration on the box, which is the same, but there's a difference between the weight of the man and the box. Okay, so maybe the box is 18 kilogram, but the man is not 18 kilogram. Okay, so that is law of acceleration. Maybe the speed of the man is proportional to the speed of the box, but the weight is not the same. Okay, that is law of acceleration. Also on the baseball bat, the acceleration applied by the baseball bat is the same with the man and the baseball bat and the ball, but the weight is different because the ball is lighter than the man and the bat. Okay, that is law of acceleration. Okay. So another example. So maybe the speed or the acceleration applied by the man pushing the car is the same, okay, with the car, right? But they have different weight. Okay, so there's a difference between the weight of the man and the weight of the car. Maybe the car is much heavier than the man. Okay, so that is law of acceleration. Okay, so as you can see on the video, okay, so the first man on the green car, okay, the second man, the third, and the fourth have different speed or acceleration because they are carrying a different weight of object. Okay. Okay, so again, that is law of acceleration. Can you say law of acceleration? Okay, very good. Okay, now there is also a formula used by law of acceleration, but we're not going to focus on it for this lesson. Okay, what we're going to focus is the law of acceleration, but I want you also to know that formula, which is acceleration is equal to the force applied on object in Newton over mass of object in kilogram. Okay, just remember it because we're going to discuss it also on the next coming lesson. Okay, so again, the second law of motion is law of acceleration. What is the first one? Say law of inertia. Good. Second one, law of acceleration. Okay, good job. Now, let us proceed on the third or the last law of motion, which is the law of interaction. Sorry. Again, can you say law of interaction? Good job. Okay, so what is law of interaction? Okay, can we all read? For every action, there is an equal but opposite reaction. Again, let me repeat. For every action, there is an equal but opposite reaction. What does it mean? Look on the picture. So there is two people in the first picture. There's a man and an elephant, or a small creature, and there's also two men pulling each other. Okay, so it means that, for example, the man pulled, okay, when they pull each other or the rope, there's an opposite reaction. Maybe the other object, or the other what they call this, man feels heavier, the other man feels tired. So that's law of interaction. So as one side is giving an action, the other side have opposite reaction. Okay, if you pull the rope, okay, the man will be pulled towards you. Okay, and if the other man pull also the rope, it will have an opposite reaction, wherein the man will also be pulled, but it can be also described as they will pull each other. Okay, it depends on how the action is being done. That is how law of interaction is being explained. Okay, so on the second picture, as you can see, so the man is pulling towards, or pulling the rope between the elephant and a small creature. Okay, so there's an opposite reaction if the man is pulling the rope with an elephant, and there's also an opposite reaction if the man is pulling a rope with a small creature, right? So maybe with a small creature it will be much easier, not too tiring, but with the elephant it is more tiring. Okay, that is law of interaction. Okay, so in every interaction there's an opposite reaction. Okay, so there is also a formula, okay, for law of interaction, but again, we will not focus on it. So we're going to discuss it on the other lesson. Okay, so again, the third law of motion is law of interaction. Can you repeat? Law of interaction. Okay, very good. Okay, so those are the things about the three laws of motion. So let us review each one of it. Okay, so the first law is, can you say law of inertia? Okay, very good. So this is the law that if the object stays at rest, it will stay at rest. If it moves, it is moved because of another object. Next, second is a law of acceleration. Okay, so on this part, the acceleration is the same or proportion to the force, but it is different on the weight. Okay, there's a difference within the weight. Okay, and the last one is, can you say law of interaction? Okay, very good, law of interaction. So law of interaction now focuses now on that in every action there is an opposite reaction. Okay. Okay, so if you have questions and clarifications, feel free to message Miss Jazz or ask your parents about it. So if they can help you, and if you need more clarifications, you can just message me. Okay, and with that, I want you to get ready with your whiteboard marker. So since we're done with our review, with our discussion, I think we can now proceed in our review time, activity 1. Okay, now kindly please get ready with your whiteboard marker. Okay, because Miss Just will pose some questions, and all you need to do is to write A or B, or choose the correct answer. Listen carefully, or you can read it on the screen and listen carefully. Okay, I'll be counting until 1 to 5 as you answer or write your answer on your whiteboard. Are you ready? Thumbs up if yes, thumbs no if not. Okay, I think you are ready. Let's start. So the first question is, he discovered the 3 laws of motion and law of gravity. Again, he discovered the 3 laws of motion and law of gravity. A. Albert Einstein, B. Isaac Newton. A. Albert Einstein, B. Isaac Newton. Is it A or B? Go. 5, 4, 3, 2, 1. Whiteboard up. Okay, let's see the correct answer. Okay, the correct answer is letter B. Okay, next. For the second question is, an object at rest stays at rest, and if moving, will keep moving in same velocity unless there is unbalanced force. Again, an object at rest stays at rest, and if moving, will keep moving in the same velocity unless there is unbalanced force. A, law of inertia. B, law of acceleration. A, law of inertia. B, law of acceleration. 5, 4, 3, 2, 1. So the correct answer is law of inertia. Okay, so if you're correct, that's very good, and if not, it's okay, you can try again. Okay, so the third question, get ready. For every action, there is an equal but opposite reaction. Again, for every action, there is an equal but opposite reaction. A, law of interaction. B, law of acceleration. Again, A, law of interaction. B, law of acceleration. 5, 4, 3, 2, 1. So the correct answer here is law of interaction. Okay, so if you got it correct, very good, and if not, it's okay. More review. Next question is acceleration of an object is directly proportional to the force and inversely proportional to the weight of the object. Not to the force and inversely proportional to the weight of the object. A, law of interaction. B, law of acceleration. 5, 4, 3, 2, 1. So the correct answer here is letter B. Okay, if you got it correct, very good, and if not, it's okay. Okay, so let's go to the next one. Look at the picture. Okay, look at the picture. So what does it describe? A, law of inertia. B, law of acceleration. 5, 4, 3, 2, 1. So the correct answer here is letter A. Okay, if you're correct, good job. And if not, you can try it again and review more on this part. Next picture. Observe carefully. Is it A, law of inertia? B, law of acceleration. A, law of inertia. B, law of acceleration. 5, 4, 3, 2, 1. So I think the correct answer here is letter B. Okay, so if you got it correct, good job. And if not, let's try it again. Next picture. Is it A, law of interaction? B, law of acceleration. 5, 4, 3, 2, 1. I think the correct answer here is law of interaction. Okay. Okay. Now, which is the formula for law of acceleration? Again, which is the formula for law of acceleration? A or B? Again, A or B? Go. 5, 4, 3, 2, 1. I think the answer this here is A. Okay, good job if you got it correct. And if not, it's okay. Let's try it again. So next, which is the formula for law of interaction? Again, which is the formula for law of interaction? Is it A or B? A or B? 5, 4, 3, 2, 1. So I think the correct answer here is yes, it's letter B. Okay, if you got it correct, good job. Okay. So we're done with our activity one. So I think we can now proceed on the next activity. So we're done with our review, our discussion and review activity one. So let us now proceed and review activity time two. Review time activity two. Now, I want you to prepare, okay, your module, get your module, and please answer your module from page 4. Again, please answer your module from page 4. That is review activity 1 for 5 minutes. So again, kindly answer your module, page 4, science module, page 4 for 5 minutes, and the timer starts now. You have 5 minutes, okay? So I'll be waiting for you to answer your module for 5 minutes. 4 minutes. Three minutes more. Two minutes, please. Kindly review your answer if you're done. You have still 2 minutes. One minute more. Last 1 minute. Thirty seconds. 20 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, ball pens up. So kindly take a picture of your module, please. Okay, kindly take a picture of your module. Okay, and kindly send it to me, or you can upload it on Orange application. Okay, so again, what's for today? So we're already done with our review, for our discussion, for our review activity 1, and for our review activity 2. Okay, so if you have questions again, you can message me anytime, okay, to clarify some details, okay? And reminders, please answer your module from page 5 to 9 again. Reminder, please answer, or reminders, please answer your science module from page 5 to 9 during your asynchronous time, which is Tuesday and Thursday. Kindly accomplish your science module from page 5 to 9, okay? So that's all for today. So before we end, may I know how are you again? Give it a thumbs up or love or smile or wow if you are happy with our discussion, or a sad face because you still need to know it, or an angry face because there's still something that you need to learn more about it. So in 3, 2, 1, go. Let me see it. Okay, so again, whatever you're feeling, I hope that this lesson gave you, not will, but gave you an opportunity to learn new things today and to explore things around you. Okay, so with that, okay, let me greet everyone. A goodbye, everyone. Goodbye, class. So have a nice day. Be safe, and I hope to see you again next meeting for our next topic. Okay, bye. Okay.